minutes.
Wait, no. Is it 40?
I believe it's 20, but I'd go for 40.
Hey.
Maybe I'll go on for longer than I was anticipating. Good afternoon, ladies and gentlemen. My name is Buck. I'm a software engineer at PayPal. I've been working there for about 6 months, which means that about 7 or 8 months ago, I was spending most of my time doing coding interviews. And I did a lot of coding interviews. I think I talked to 10 or 15 different companies in my last job search. So I did a lot of algorithms questions. And by the end of my job search, I was beginning to find them quite irritating and repetitive. And with software engineers, when you give them an irritating and repetitive task, they start looking for a way to automate it. And so I decided that by the time I next looked for a job, I was going to have a system which would automatically do my algorithms questions for me. So this might sound like a confusing and lofty goal. I'm interested only in the subset of this task where you're trying to convert, where the problem isn't to specify some behavior. So you can walk into an interview and then they can ask you to write code to reverse a linked list. I'm not interested in solving that kind of question. I'm interested in solving the kind of question where it's obvious how to specify it somehow and you don't get points for that. But the question is how to do it well. So let's look at a pretty standard example question of this type. This is from cracking the coding interview. So we want to have a stack which, in addition to push and pop, has a function min which returns the minimum element. Push, pop, and min should all operate in constant time. That makes sense, guys? Cool? So let's look at a bad implementation that doesn't work. Well, it works. It's just not fast enough. So this is some basic Scala. We want to push and pop. And the problem is this getMin operator, which doesn't work because it takes linear time. Does anyone off the top of their head know the solution to this? Yeah, go to it.
Second stack.
Yeah, you want a second stack that's like this. So the second stack is going to maintain the smallest thing that you've seen so far. Every time you push, you see if the minimum has changed and push the minimum to this second stack. And when you pop, you just push both. And this means it's constant time for both. So let's imagine that the question is now slightly different. What about if you're allowed to do random modification to your stack? So I'm allowed to say, actually, the thing at position 5 is now 20. Can we do this with a stack anymore? No. So the answer is our efficient solution, which involves the second stack, breaks as soon as we are allowed to make arbitrary modifications to our stack. So in that case, our previous data structure wouldn't work. But what about if we're allowed random modification, but the question is to return the sum instead of the minimum? And that'd be easy, because you just have to store the total sum of everything you've seen so far. When you add something, you add that to your sum. When you remove something, you subtract it. So what we've learned is that when we're trying to find fast data structures for particular queries, we're interested in 2 questions. What kind of reads are they going to be making? Are they going to be asking for minimum or the sum? So the kind of property that makes the difference there is whether we're doing an invertible reduction or not. The reason that you can just store a single number to keep the sum is that you can invert subtraction. Sorry, you can invert addition with subtraction, right? But there is no operation which inverts taking the minimum of 2 numbers. So that's one question we're interested in. The other one we're interested in is what kind of modifications are happening to our data structure. So in the case of a stack, that's basically the data structure where you are promised the only modifications is adding elements to this end over here. And that means that it's really easy to maintain various invariants. Cool. So let's look at what my system can do at the moment. So one of the big lessons I've gotten from this conference so far is you always want to have dark backgrounds in your consoles. Was anyone at that talk? Yeah. So this is a question that I was asked at Google, actually. So the question is, I'm going to be giving you people one at a time, and I'm telling you about them. And I want you to store, for every nationality, the 10 richest. So I want to be able to ask, this return type is totally a lie, but I don't actually check it, so So I want you to be able to give me the 10 richest people of every nationality. So we can look at the implementation here. We're going to filter by the nationality of the person equaling this argument. And then we're going to limit by is basically an order by and then take. And we want to get the top 10. Does that make sense? So let's compile this without the O2 flag. And we get this Ruby code. Long story as to why it's turning into Ruby, but I will explain later. And we get this shitty implementation where we select them by having the right nationality, then we sort them by the negative of their income, and then we take the first 10. Does that make sense? Cool. Let's turn on this O2 flag and compile it again. Now things are very different. We've got this variable which has been helpfully named z, which is a hash map of empty min heaps. So let's see what happens when you insert a person now. Well, it pre-calculates their priority, which in this case is just the negative of their income. Then it looks up if it basically stores a min heap of the top 10 people. If this person is richer than the 10th richest person, then we need to pop the 10th person out and then push this new person into our min heap. And then we have this case here, just in case we're at the start and we don't have 10 people for this nationality yet. So this is the fast implementation. This takes constant time, guys. And when we ask for an insertion, it inserts it into the heap, which is indexed by a hash map. And when we try to read, we just get a list of keys from the heap, which is at that place in my hash map. So that's the kind of thing I can do. I'll just quickly show you another example. We want to get the average income of, that's output. We want to get the average income of people who have a particular age and gender, and gender is a string field because I'm not some kind of monster. And we get the total income here, and we get the count here, and we're going to compile it with O2. And we end up storing two hashes of hashes. When we add a person, we add one to the number of people who have that gender and age, and we add their income to the total income of people with that gender and age. And then when we want to get the average, we just divide them. My system is not very good yet at realizing that we should use division instead of exponentiation. But whatever, cool, that's what I'm doing. Question is, how do you do that? Luckily, Tobias has got many of you guys warmed up for phases of an optimizing compiler, so I'm going to talk about that. This project is currently about 3,000 lines of Scala. Okay, so the Java string that you pass gets turned into a Java AST thanks to the Java parser library, which is referred to as com.github in its package name, so I guess GitHub has something to do with it. I didn't write any of that, so let's talk about the next bit. First thing I do is I want to turn method calls that are chained, like .filter, .limit by, .reduce with sum. I want to turn those into SQL-style queries because it turns out that that makes it a lot easier to optimize. So let's look at this SQL query quickly. I'm going to point out a few parts of it, which I'm going to use in my query data structure. Here we have the source. So this is where we're going to get our data from. It, in my system, has the type Java expression or query. In this case, it's just a reference to the variable people. Then we're going to have a list of where clauses, or a set, sorry, because where clauses are commutative. You can swap their order. So one of the where clauses is the height of a person has to be greater than 180. The other where clause is age has to be less than 40. That makes sense? Next thing is what I'm calling my limit by clause. Note that in this case, we don't actually care about the order of people's heights because we're just limiting them and then taking the average. So order by is basically the composition of a sort by and then a take where we don't care about the order. That's basically because I'm only looking at the unordered case of making fast queries at the moment. It's a mild hack that I'm doing at the moment. It's represented as an option of limit by clause because we might not have one. And finally, we have this maybe reduction, which is a thing which takes the list of things that return and reduces them down to a single value. Why is this an option of reduction? Like, what happens in SQL if they're, like, what's the kind of the null case for a reduction there?
Star.
Yes, star. So it's like very possible to just return everything that's in there. So we end up having this case class for an unordered query, which has a source, a set of where clauses, maybe a limiter, and maybe a reduction. And the queryfication step basically walks over my Java AST, and then everywhere it can stick in an unordered query, it does. And the logic for that is pretty complicated, but like an example of it kind of looks like this. When you try to call filter on a query, we want to look at whether we are currently, like whether we're calling query on, whether we're calling filter on a query which has no limiter or reduction. In the case where you have no limiter or reduction, we can just add the clauses in this filter to that query and return that. Otherwise, we need to make a new query and like call where on it. That was kind of complicated and fast, but I'm going to speed through it anyway. I promise it makes sense. Feel free to check out the source code. One fairly major component of the system is a computer algebra system. So to figure out things like, you remember the case before where we were talking about a sum list versus a min list, where you have to maintain the sum versus the min. whether it's possible to do this is quite closely affected by whether your functions are invertible. So I had to write a computer algebra system that can determine things like how to solve expressions. This is really hard. It turns out that there are only a few libraries in the world that do a very good job of this, and I want to do a much more ambitious version of it where it can, for instance, tell you that you can invert bitwise XOR or whatever. That is a whole other talk in itself. But it's a major weakness of this system that I am not better at it. Currently, the only thing I know how to solve is basically of the form, it's a sum with nothing complicated in it. If you tell me that 0 equals x plus y plus z, I can solve for x, is basically all I can do, or y or z. Cool. So after that, we've gone through our abstract syntax tree, put queries in everywhere. Now we need to choose data structures. So what is it that I mean by a data structure? Well, here is most of the abstract class which provides the definition. So a data structure might be something like a constant-sized heap, which knows that you should pop elements out if you're about to stick in a new element. So it has an asymptotic query time, which is a thing expressed in big O notation, which in the case of a constant-sized heap is constant. It has an insertion fragment, which means a list of Java statements that you need to do when someone is inserting something into your data structure. It's got a list of things you need to do when someone's removing them. Who knows why that's an option of list of Java statement instead of just a list of Java statement?
Might not support the operation?
Yes, not all data structures support insertion and removal. If we've got a Bloom filter, it's not going to support removal. And in the case before where we were talking about if I want to maintain the minimum of something, it's really easy to just support that if no one's removing anything by just keeping it in one place. So in that case, my removal fragment would be none. Very good. I also have query code, which is the Java code to be executed when they want to actually get the value out. And that can optionally call a method which is emitted to encapsulate that code and is special for this data structure. And then the question is, for every query, how are we going to choose the best data structure for it? So in the case where we want to limit by something and then reduce by something, how are we going to do that? Well, we have a list of helpful structures. Then for each of these structures, a structure means something like constant-sized hash map or monoid memoizer or group memoizer. It tries to create an instance of that useful class with my query. Then, of the ones that worked, it's flat map because try to create returns an option of query. Then we filter so that for every data structure, it either doesn't need to be able to insert or it has an insertion fragment. Then we filter so that it either doesn't need to be allowed to remove things or it has a removal fragment. Then we sort by asymptotic query time. Then we take the head. And this is an option because maybe there is no data structure to represent the operation efficiently, in which case we give up and return the shitty .filter, .sort by, .take, or whatever that I showed you before when my optimization flag was off. Okay, that was a lot of Scala. I'm glad that you guys are smart enough to get through it. What data structures do I have? Currently, I only have pretty much the ones you've seen. I can maintain the minimum of a reduction where we don't need to be able to remove things. I can maintain a thing which has invertibility, and I have this limited size heap. Why did I not put more work into that? Because it's fundamentally not that interesting compared to creating the internals of all this stuff that I'm doing. I will probably add more of them. I'm not going to talk about monad memoizing KD trees. Okay, so next thing we do, we've chosen our data structures, and we need to actually put them back into our Java abstract syntax tree. It's pretty much just walking over it again and replacing every time they call the query with the code that was defined in the data structure to answer that query. It works, I promise. The other trick is when someone inserts into your class, you need to output all of the other things you have to do when they insert. So you guys might remember in my example, the insertion ends up also updating these two hash maps, right? And that's done by literally calling the insertion fragment kind of methods for all of the data structures which are being used and splashing them all together and returning it as a method. Okay, whoa! So that's how we actualize them. And then finally, we've got a Java abstract syntax tree, which is basically legitimate Java, and we have to turn it into Ruby, which is just walking over a tree and putting brackets, places, and omitting types. Hey guys, why is it that I used Ruby as my target language? What's that, sorry? All right, because I'm too lazy to include types everywhere in my abstract syntax tree. That's also why I chose Java as my source language, because it has types everywhere. In the future, I'll probably do a better job of this. Lessons I learned about Scala from this process, basically, I really want type union as in an anonymous way of expressing the thing which I pass you will be this type or this type. There are ways of doing this in various libraries, but I wish it would directly build into the compiler. I also want type minus. When I'm representing a sum, I don't want any of the things, so sum is a case class which extends mathematical expression, right? I don't want anything in my sum to itself be a sum, because if it was going to be a sum, I'd want them to just flatten it out, right? Like with the blocks in Scala.js. And I want to be able to express the summands in this sum must not be sums themselves. You can do that in Scala, but you have to use some crazy stuff that you can only find in a Stack Overflow answer by Miles Sabin, which is not robust software engineering. So that's my main lesson about Scala. Where to go from here? More data structures. I would love to have some quasi-quote style specification of your data structures, because currently the way that you explain to my system how to use a constant sized heap is basically literally writing a Java abstract syntax tree manually, which is really irritating, and I would love to do better than. I would like to have more correctness. The functions I showed you were only slightly cheating, but a little bit cheating, because I don't do a lot of analysis that I really should. I assume all functions are pure and referentially transparent, which citation needed is not true in Java, which is dangerous. I want to extend this so that I can talk about ordered collections, so that I can actually answer the minimum query, the min stack question, which I mentioned at the start of this presentation. I want to automatically solve dynamic programming problems as well, which turns out is kind of related to this. I would love to have auto-generated test cases so that when you tell me about this new neat data structure that answers a query really fast, I want to automatically create data structures that figure out if you use that in the code, does it produce the same result as just doing the inefficient, obvious implementation? I could do that automatically, I just haven't. I also want more target languages. Python would be nice. I want to generate C extensions for Ruby automatically, because it's not even that hard, but it's tricky and people don't know how to write C extensions for Ruby normally, and that'd be fun, and then I could have a website where you pay 99 cents to download a C extension to Ruby which has your domain-specific logic in it, and that'd be neat. So in conclusion, if I had to basically express what I'm trying to do with this, there are all kinds of things that people don't do when they're writing code. Imagine that I actually gave you this problem here, right? In real life, chances are you wouldn't want to actually store these hashes of hashes and update them everywhere, because that's really hard, and software engineers are bad at doing complicated things and keeping their data in step. People dislike denormalizing their data for a reason. I want to make it so that this kind of data denormalization is totally automatic and takes no marginal effort on the part of the programmer, and so happens more easily. And I want it so that next time I look for a job, I can cheat on all my phone interviews. I have had a very good time writing this code. You can see the various different haircuts I've had. This is lol commits. Strongly recommend installing. Thank you very much. Any questions? Hey, what's up?
How do you turn into SQL?
Oh, I don't actually, the question is how do I turn my code into SQL? I don't actually turn it into SQL. I just turn it into this data structure which kind of looks like SQL and could be transparently converted into SQL. But good question. What's up?
Since you're parsing the Java yourself, is there a subset of Java types that you're allowed to use in your specification?
So I don't parse the Java myself. I use, is there a subset of Java types which I allow people to use? A lot of the types I don't actually look at when I'm writing this code. The only place where I actually consider the types of things is when I'm looking at objects which have methods called on them with names like filter, and I'm saying, hey, should I turn this into a query? And then I inspect it to see if its type is magic multiset. there are a lot of things which, like, my compiler would totally let you do, which are totally illegal to do. Is that a question over there? Hey, Sergey.
So what kind of operations are you recognizing in Java? So you said
Yep.
average, sum. Do you have a specific idea of what kind of operations you're looking at? Or just
Yep. So you guys might remember transducers. I totally should have mentioned that buzzword in the main talk. But yeah, so basically I do filter, limit by, reduce, various things which you can write as reduce. So you notice that I used count somewhere or sum. Count and sum are both just shortcuts for things which are turned into reductions internally. If I extend this to ordered collections as well as unordered collections, then there's a whole set of different things which make sense for them, such as order by and take and drop, as well as a more complicated set of modification methods, such as push and push to the other end, and insert and set, and so on. Hey.
If you were the interviewer, what question would you ask?
If I were the interviewer, what question would I ask? Now the problem is, the questions that are asked here are actually pretty much my favorites. Like, the thing that really annoys me is when people ask me questions that aren't about asymptotic complexity defining. You know, if people ask me about, you know, how to swap two variables in place without using a temporary variable, it's just like, you know, I have nothing useful to say to you here. I would ask people to build an interesting and complex system which requires them to develop novel abstractions and talk about it. So I'd probably just ask them to talk to me about this system, actually, at this point. I wonder how that goes, walking into an interview and saying, hello, your questions are bad. May I suggest some new ones? I'll give it a try. Anything else?